Okay, so the chapter 6 notes, we're going to kind of skip around. So I can kind of talk about these next couple examples, but we're not actually going to do them. So we talked about the average value of a function. Remember, the average value of a function is the average height of all the infinite rectangles. All right. So if I was going to find the average value of a function, you do 1 over b minus a, and then you multiply by f of x dx from a to b. All right, so it says in Indianapolis, the temperature in degrees Fahrenheit, T hours after 9 a.m. was modeled by the function given. Find the average temperature from 9 a.m. to 9 p.m. Okay, now this is kind of tricky. When you think about the setup, what is your A to B? What's your interval?
0 to 9 plus
12. 0 to 12, right? Exactly, you need 0 to 12. So it would be 12 minus 0, and then you'd put in the function. Now you can easily find this with Math 9. So you guys could do this if you want. It would make sense that it would be a degree in Fahrenheit. That would kind of be the average temperature over how many months? I guess over the whole year, right?
So it should be like 12,000.
Yeah, you're not going to get like 12,000 degrees Fahrenheit. Okay. So it says on the interval a to b, will there always be a value c where f of c equals the average of f? I don't know. In this case, would there be? As long as it's continuous, there will be. So write yes as long as your function is continuous. Does it make sense? That's using the intermediate value theorem. I can't talk today. So there's always, as long as you have a continuous function, it always has to go through every single value between the two endpoints. So yes, by the intermediate value theorem, as long as it's continuous. All right, so the mean value theorem. This says exactly that. It says if f is continuous on the closed interval a to b, then there exists a number c in a to b such that f prime of c is equal to, or sorry, f of c equals 1 over b minus a from a to b, the interval from a to b of f of x dx. Sometimes you'll see this written as this, so both ways. So there exists a c value where its height equals the average value. Okay, does it make sense why we call this the mean value? Because it coincides with the average value of a function. All right, so mean value theorem, it coincides with the average value. All right, now this is confusing because you guys have learned the mean value theorem for derivatives. Now there's a mean value theorem for integrals as well. So this is another one that you need to know. So know how to find the average value of a function, know this as well. These are all flashcard things. All right, so number 1, it says find the average value of f of x equals x minus 3 squared on the interval 2 to 5. So we could do that. So we do 1 over b minus a, the integral from 2 to 5 of x minus 3 squared. We can find this by hand by FOILing out, finding the antiderivative, and so on. We're actually going to use Math 9. So go ahead and get out your calculator and do Math 9. So the way you should put that in is you hit Math 9, so it comes up with finite integration. You're going to do parentheses x minus 3 squared, comma, x 2 to 5. And then you're going to multiply by 1 over 3, or divide by 3. In the end, you should get 1/3 times 3, so you get 1. So the average value of that function is 1. So find a value c such that f of c equals the average value. So we want to find f of c equals 1.
Wait, I got 3 for the first one.
Yeah, but you had by what?
Yeah.
Because in the front.
Because this right here.
5 minus 2.
Why did I get 3?
right, so we're finding when x
Wait, Amanda got 351. Like this.
Okay, so find when x minus 3 squared equals 1, guys. So take the square root of both sides.
That's what mine is. And then you got the right equation?
Yeah. Oh, I used the negative sign instead of the minus.
How did I do that? Thank you.
All right, so I would take the square root of both sides, write plus or minus. So you get x minus 3 equals plus or minus 1. Add the 3 over. So I get 3 plus or minus 1. So I get x equals 4 and x equals 2. Okay. Ooh, there's actually two numbers. So there exists a number in the closed interval, right? So it could be either one. So that's just on the endpoint, right? The 2. All right, we can kind of skip the next one. So it says find the numbers b such the average value on the interval 0 to b is equal to 3. Do you guys know how you would do that one? So if you're on the interval 0 to b, you need to do 1 over b minus 0, 0 to b of 2 plus 6x minus 3x squared. Maybe we should do this. And we want to find when it's equal to 3. So you'd have 1 over b out front. You'd integrate. So 2x minus 3x squared minus x cubed. Sorry, plus 3x squared, right? And that's going from 0 to b. You want it to equal 3. You can make it a little bit easier by multiplying by b, just so you don't have that 1 over b out front, so you have 3b. Then plug in b, so you get 2b plus 3b squared minus b cubed. All of that's going to be minus 0, right? Plug in 0. And then you can solve. Like I said, we're going to skip around pretty quickly. This would be something you could pull the b out and then you could factor. All right, moving on. Section 6.4, Fundamental Theorem of Calculus. All right, obviously it's pretty important. It's called the Fundamental Theorem of Calculus. So this is the most important theorem in all of calculus. Basically, it just establishes the connection between the two branches of calculus. So the first semester is differential calculus, so derivatives. Second semester is integral calculus, so antiderivatives. So when calculus was first created, there were two problems to consider. So how to find the slope of a tangent line, how to find the area under the curve. They seemed unrelated at the time, but Sir Isaac Newton's mentor, Isaac Barrow, discovered the relationship between the two. So at first, they weren't even connected at all. I mean, they kind of were connected with like limits, but we didn't know that when I took the derivative of one, I got the function and then derivative again, you know. So we didn't know that derivatives and antiderivatives were opposite each other. So it says if f is continuous on a to b, then the function defined by, you guys have that, right? Yeah. Okay, so the integral, so g of x equals, oh wait, define, I don't know how I had it in my notes. Did I do this? A to b. Where f is any antiderivative of f. In other words, capital F prime equals little f. I don't know why I have the function g. We'll say this equals g of x. So say equals g of x. That g of x will be important later in the second part. All right, so compute the following using the FTC, the Fundamental Theorem of Calculus. So this is the shortcut method. So I taught you this long ago. We're now using the shortcut method. So fair game on 6.4. So all you do is x cubed with a 1/3 out front minus x squared. We're going to go from 0 to 2. So I took the antiderivative. Now I'm going to plug in 2. I'm going to find what that is. And then I'm going to plug in 0. And I'm going to find what that is. Obviously, I can tell already that that's 0. All right, so I get 1/3 of 8, so 8/3 minus 4 minus 0, so 8/3 minus 12/3, so it's negative 4/3. So when you get a negative out, that's okay. We're not really talking about the area, we're talking about the integral, which can be negative. Basically, most of your curve was under the x-axis, so that's what it means for a negative integral. All right, if I was going to set up the next one, you guys would have to change it first. It'd be x to the 1/2 minus x to the negative 2. Do you guys know how to do all this? Can I skip it? I'm not hearing a lot of yeses, so maybe I should do this. So x to the 3/2, right? Add 1 to the power. Do 1 over that power, so the reciprocal out front. Add 1 to the power. It would just end up being plus 1 over negative 1. Or no, 1 over negative 1, negative. No, it is plus. And then it goes from 1 to 4, because it was already a negative, so now it's 1 over the negative 1, made it another negative. All right, and then plug in 4. So you get 2/3, 4 to the 3/2. 4 to the negative 1 is 1/4, sorry. And then 2/3 plus 1. Okay, you can simplify that. Anybody have it simplified? I think you get 47/12. So 47/12. Thank you. All right. All right, so finding the area under the parabola y equals x squared from 0 to 4 is very easy. That's all above the x-axis. So if I'm going from 0 to 4, you're just setting up the integral. So 0 to 4 of x squared dx, that's going to be your area. So it'd be x cubed with a 1/3 out front. I sometimes write that as x cubed over 3, so don't be confused when I write that. That's the same thing, right? 1/3 x cubed. All right, going from 0 to 4, so it's 64/3. All right, this one's a little different. It says the cosine curve from 0 to b, where b is between 0 and pi/2. Pi/2 is where it crosses the x-axis, right? Because cosine of pi/2 is equal to 0 there. All right, so some b value, we don't know where it is. It's somewhere between 0 and pi/2. Okay, so basically that cosine curve is above the x-axis. So when we talk about the area, it's just a simple integration from 0 to b of cosine x dx. If I integrate cosine, so what do you take the derivative of in order to get cosine? Sine. Sine. Now it's confusing once you learn antiderivatives, isn't it? So plug in b, so I get sine of b minus sine of 0. Be really careful. I guess this one's okay. But sine of b, and then what's sine of 0? 0. It goes away. So be careful, because there was one like this on a multiple choice question one year, and a lot of people missed it because they assumed it was cosine of 0 when you for that problem. And they were like, oh, cosine of 0 is 0. Be careful. When you plug 0 in, it's not always 0, right? So if it had been cosine of 0, you would mean 1. Okay, so sine of b would be your answer. Okay, so sometimes you need to break up the interval. This will happen if the graph hits the x-axis or goes below the x-axis in future sections. So if I have 2x minus 1 in absolute values, you guys can do a little t-table if you want to figure out what that looks like. I kind of use transformations. So do you guys remember transformations from Algebra 2? Yeah. Yeah, you guys didn't like them then. This goes right 1. What's the 2 tell you? It's a compression by 1/2. Yeah, horizontally. Actually, I totally lied. This doesn't go right one. I'm thinking of those as parentheses, and then it's being squared. All right, so if you just had y equals 2x minus 1. No, I think we were right. We were right. See, that maybe I shouldn't do this. Now I can use the excuse that it is Monday, because it is Monday. All right, so let's just do a t-table. So if I'm messing up, you're probably going to mess it up too, right? So let's plug in like 0. If I plug 0 in, I get -1. If I plug 1 in, I get 1. Yeah, so -1 would be, I guess, 1, right? If I plug 1 in, I get 1 in absolute value, so 1. If I plug in 2, I get 3. Now let's plug in some negatives. So let's plug in -1. If you plug in -1, you get If you plug in -2, 5. Okay, so let's sketch. We know it's going to be a V shape. So I have 0, 1, 1, 1. So it looks like the V is going to be directly between those, right? It's very symmetric. So it's going to be, let's plug in 1/2 just so we can see it. So if I plug in 1/2, that's when you get 0, right? All right, so here's my V shape. All right, I'm going from 0 to 2. So I have this little bitty triangle to 1/2, and then I have another triangle from 1/2 to 2. So if I was finding my area, I have the little bitty triangle, which is 1/2 base times height, plus the other triangle, which is, what's its base? 3/2, right? 1.5, and then height. So we need to find its height there. So if you plug in 2, what did you get? 3. So I have 1/4 plus 9/4, so you get 10/4, which is 5/2. So 2.5. Do you guys think you can do absolute values with Math 9? Yeah. So if this had been a calculator question, which usually these aren't, usually you have to kind of look at them, you could do Math 9 as well. Just make sure you do absolute value. All right, so in order to use the fundamental theorem of calculus part 2, you need the equation g of x equals the interval from a to x of f of t dt, where f is a continuous function on a to b and x is anywhere between a and b. Okay, this is really confusing when you guys first learn this, so here's what I'm saying. It doesn't actually have to be positive, but that's probably the easiest way for you guys to see it right now. And let's say a is here and b is here. X is any value between it, and x actually varies. So if I was talking about a to x of f of t dt, so my curve is f of t. You don't want to use x because we're using x in another way. All right, what is it right now? Think about the picture. What is it? What is g of x? It's between a and x, and it's the area under the curve between the x-axis. That's what it is. But x is varying. So do you see that g of x is this new function? So if I wanted to find g of 1, g of 2, g of 3, I could find all of those different values. You get it? Yeah. So x is going to vary, so g of x is going to be that new function, which is just the areas. So it's all these different numbers that you get from the area as x changes. Very strange. I think I have an example. So number 1, so if f is the function whose graph is shown below, so that's f of t, and g of x is represented by the integral from 0 to x f of t dt. Find the values of g of 0, g of 2, g of 3, g of 4, g of 5, g of 6, and g of 8. Okay, so we're creating this g of x. You're going to see these different values. It's like we're doing a t-table for g of x. All right, so if I have g of 0, so that would be the integral from 0 to 0 of f of t dt. What would it be? 0 to 0? 0. There's no width there. All right, g of 2. This would be the integral from 0 to 2 of f of t dt. So we're saying the area from 0 to 2. So we find that area. It's 1/2, the base is 2, the height is 3, so it's 3. So that's what g of 2 is. Now we find g of 4. G of 4 would be 0 to 4 f of t dt. That's okay. All right, so what's g of 3 then? You just add on this much more, right? So you get 3 plus 3, so you get 6. Good. G of 4, 0 to 4 f of t dt. Do you see that g of x is a function? It's changing. We can find those values for g of x. So f of t dt from 0 to 4 would be 3 more. 9. G of 5. So I still need to write the integral, or you guys get it. G of 5 would be adding on this little bitty triangle. So it's 9 plus 1/2 base times height. So 9 plus 1.5, so 10.5. G of 6 and G of 8. Ooh, G of 6 is a little hard. What's G of 6? It's negative. So now you're subtracting out that 1.5, so you're back at 9. And what's G of 8? So adding on this little triangle here, and it's negative. Yeah, so now you're subtracting out, so you have minus 1/2 base times height. So it's 9 minus 3, so you're back at 6. Okay, does that make sense? Okay, so g of x is a function. So g of x is the area as it changes as x moves. Okay, so that's going to bring us to the fundamental theorem of calculus part 2. So if f is continuous on a to b, then the function g defined by g of x equals a to x f of t dt, where the function is continuous, so g is continuous on a to b and differentiable, then g prime of x equals f of x. Okay, this is very strange. I know it's weird, but this is what I'm saying. If I had the integral from, I don't know, 5 to x of something very weird, e to the negative t over 2 times sine of t over 5, something weird like that. So if I had that strange function there, and I asked you to find the derivative, it just becomes, it becomes this regular function with x plugged in. So it just equals e to the negative x over 2 sine of x over 5. So why do you guys think that is? You haven't taken the derivative. But derivatives and integrals are opposite each other, right? But the thing that gets everybody mixed up is this 5 doesn't matter. As long as it was any number, it's always the same thing. Okay, and that's the part that people don't like. So here's what's the easiest way. I used to do like a big long proof of this, and then I found that my students hated it. So I've just stopped doing this big long proof of why this is true. But I'm just going to show you in like one step why this is true. So if I had the integral of f of t dt, and I was going from a to x, so no derivative up front at all. What does that mean? It means that it would be capital F of x minus capital F of a, right? We understand that. So now let's say I take the derivative of this whole side. What happens when I take the derivative of this whole side? What's the derivative of capital F of x? Little f of x, right? What's the derivative of capital F of a? 0. Why? Yep, this is a number. So it's minus 0. So that's why the derivative of whatever this is, even if it's starting at a, it can start at 0, pi, it's always going to just end up being if you just plugged x in. Okay, now this is going to get harder. Let me show you something else. What if I had the integral from a to 2x of f of t dt? That would end up being capital F. So this is example 1. This is example 2. That would end up being capital F of 2x minus f of a, right? Now what happens when you take the derivative? No, you do get your little f of 2x times 2. Thank you. Who said that? Good job, Rachel. What did you just do? Chain rule. Think of a real life example. Like if I, well, not real life, but think of a real example. If I had sine of 2x, so sine of 2x. So that's what this was. How do you take the derivative of sine of 2x? Yeah, you do cosine of 2x. So the derivative of sine is cosine of 2x times 2. So if it's anything other than x up here, then you need to remember the chain rule. Okay? Is that a nice, like, two-step definition of what we're going to do? Yeah, it used to be like 2 pages, so made it a little easier for you guys. Okay, so that's what it says. So here's the easiest way to think of this theorem. I guess I did put it in here. So when I take the derivatives of both sides of the equation, you end up with g prime of x equals f of x. So number 1, find the derivative of the function. So if I have g of x equals the integral from 0 to x, that's your clue that you're using fundamental theorem of calculus. I guess I should say together, this is the clue. When you say the derivative of an integral and it has x, it doesn't have numbers there. Well, one of them is a number. All right, so it's just going to be g prime of x equals, you just plug x in, square root of 1 plus x squared. That's it. Yeah. When you guys see these problems, these should be easy points on your test. They should take you all of 2 seconds to find the right answer.
Why is this the fundamental theorem?
It's a fundamental theorem because it relates derivatives to integrals. So that was a big deal when that first happened. Can you imagine? I would be Archimedes, you know. Eureka, eureka. Be very excited about this. All right. Yeah, I'm going to get killed in my sandbox. All right. So this next one, what's the answer? X squared minus 2x plus 3.
Do you have to replace it with an x?
Yes, whatever variable this is right here. So sometimes you have to use the chain rule with the fundamental theorem of calculus. That's what we talked about. So in this one, think about what this is saying. If I had g of x equals the integral from 2 to x squared of cosine t dt. Let's say this is my little f of t. When I integrate, you're going to get capital F of t, and you're going to plug in x squared, and then you're going to plug in 2. So if you took the derivative of both sides, so you get g prime of x equals f, so little f, x squared times 2x, and then this part would go away. That's just a number. So in our case, so g prime of x is going to be cosine of x squared times 2x. So you can put the 2x out front if you want. So 2x cosine of x squared. Okay, so all you did is you plugged in the x squared for t, and then you tacked on a times 2x. Because if you were integrating cosine, so if you were integrating cosine, you would get sine, right, up here. But then when you took the derivative, you'd be back to cosine. Okay. All right, so this one, very quickly, you just plug in x cubed, so it's cosine of x cubed times 3x squared. That's it. So how about number 5? So compute 0 to pi of sine of t dt. How is this different than what we've been doing? Oh, x, sorry, I can't read it. I'm blind. So 0 to x of sine of t dt. How's it different? Nope. What is it missing? It's missing the derivative, right? It's not saying take the derivative of the integral. Yeah, so if you're finding this, you would do 0 to x, I keep wanting to make that pi, 0 to x of sine of t dt. So the antiderivative of sine of t, negative cosine, I heard someone say cosine, 0 to x, so it's negative cosine of x minus a negative cosine of 0. Be careful. So negative cosine of x minus, or well, plus, right? What's cosine of 0? 1. So plus 1. So it's 1 minus cosine of x. That has been a multiple choice question in the past. They like to reuse their multiple choice questions too. They never, well, they hardly ever, like the last ones that have been released for 1998. So. That I know of, at least. All right, so how about something like this? So compute the derivative from x squared to x cubed of cosine of t dt. Scary, isn't it? Because now you don't have like a number down here. So is there any way you could break it up so that you would have a number? Yeah, you could break it up with any number in between those two, right? So how we're going to rewrite something like this, and you won't see these very often, but I'm going to take the derivative of, and I'm going to rewrite that integral. So I'm going to say I'm going to go from, you could use 0 if you want, or a, or anything. So I'm going to go from x squared to a of cosine of t dt. That's an a. Doesn't really look like an a, but. Plus, now I'm going to go from a to x cubed of cosine of t dt. One more thing we're going to do. So this is from x, let me switch it. Because this first one isn't quite in that form. We always had the x squared on top. So how could we write it so that the x squared's on top? Yeah, you can take the opposite. So it's going to be negative a to x squared cosine of t dt plus a to x cubed cosine of t, or cosine of t dt. Okay, now you can take the derivative. Are you guys understanding this? Just changing things around. So now you can plug in the x squared. So you get negative out front, cosine of x squared times 2x chain plus cosine of x cubed times 3x squared. That's it. You probably write the 2x out front and the 3x squared out front.
Can you just do it like normal? Just subtract x.
Good question. So can you?
Can't you?
Looks like you can, yeah. So what you could do is think of this as, if that's your function, like that's f of t. If you had capital F of t and plugged in a to b, so in our case x squared to x cubed, yeah, it would work out the same way. So the question, why does the bottom integrand, the constant pi over 2, not matter? So I don't know why I have that here, but that's from number 4. So why does it not matter what that bottom number is? Yeah, because when you take the derivative of it, it goes to 0 anyway. Derivative of a number is 0 anyway. Okay. Perfect. I told you I could teach you trapezoidal rule in like 3 seconds, so I'm going to teach it to you. Well, 3 minutes maybe. We got 5 minutes left. I can do this. All right, do you guys remember midpoint rule? Do I need to go over that, or you guys are good? Do you guys remember midpoint rule? So if I was doing midpoint rule from 0 to 1, and I wanted it in 4 pieces, I would need 1/2, 1/4, 3/4. And what x values would I actually plug in for midpoint rule? 1/8. Do you guys remember these? 3/8. 5/8. 7/8. So you would use those heights. So the widths would all be 1/4 in this case. So I'd have 1/4 times whatever f of 1/8 is, plus 1/4 times whatever f of 3/8 is, plus 1/4 times whatever f of 5/8 is, plus 1/4 times whatever f of 7/8 is. And when I say f, your f of x is x squared plus 1. Okay, so you can find all that. So you're always using the point in between for your rectangle. So your whole rectangle goes to whatever that height was. 1/4. I don't know. Was that Catherine that said that? Okay, so the trapezoidal rule with n intervals is usually denoted t sub n. So a sketch of the trapezoidal rule is shown below. So did I show you guys the sketch or no? No. Okay, so if I have some kind of curve, and these are my intervals. They don't have to be even, they can be. Here's what you do. If you go up on the right side of the rectangle and on the left side of the rectangle, and then connect them, you have a trapezoid. Do you guys see the trapezoid? This is B1, this is B2, the height is in between them. So the height is the distance between them. So what you would do is you just go up to whatever points, draw the trapezoid between them. Go up to the points, draw the trapezoid. Like that. This gives you a very precise estimate. Much better than left hand or right hand. Especially the more and more you have. All right, I would not memorize this formula. This is only when you have an even interval. I would just sketch it out. So it says compute the trapezoidal rule with n equals 4. So if n equals 4, you're at 1/2, 1/4, 3/4. You need to find those y values that go with it. So if I had 3x squared, I'm going to find those y values. So I'm just putting them into my table on my calculator. You don't have to do that. But. So I'd have 0, 0. I'd have 0, or I'd have 1/4, 0.1875. I'd have 1/2, 0.75. I'd have 0.75, 1.6875, and 1, 3. It's up there. And you just draw on the trapezoid. So in this first case, it's a triangle. The next one is a trapezoid, though. And then a trapezoid. These should be getting more and more steep. Mine aren't drawn very well. It should look like this, right? So it should be way up there. All right, and then you can find the areas of each trapezoid and add them together. So you guys can start on 6.5. We can finish it up next time, but we'll also review next time.